Okay, here we are with the last of the floppy drive maintenance. Specifically, this is going to be cleaning and lubing. And then I'm going to investigate the power adjustment pot on this analog board. This case is pretty yellowed. In fact, I feel like the camera is making it look better than it actually looks. How's the audio level? Can you hear me okay? Gamer Bay? I heard before that it was very quiet, and I see it looks like it's quiet again. All good? Perfect. That was not the feedback I got earlier today. How's your night going? Or maybe day. I don't know where you are. This is the fourth one. They've all went pretty smooth, although I ran into a new revision, or I shouldn't say a new revision, a new to me revision of some hardware in the Mac Plus that I'm not familiar with. So a little bit of a learning experience, but generally smooth. And we'll see. It's always kind of a fun mystery now to see what I'm going to get when I open this up. This is my Mac Cracker. I usually start at the top because it's the most effective. But all this is a paper clip, a strong one, with this little lip on the front. And I can put it in the seam and use these pliers to squeeze it a little bit. So the next best place is the side. And I can see it's working. I usually go slow. I only want to lift it like a couple of millimeters to open up that top. Do the same over here. Ooh, it is stiff. It makes me nervous. Oh man, that's stiff. Oh, I actually remember this one. I had this open a couple of weeks ago. And you will see why I remembered it. And you'll probably also figure out pretty quick why it was so stiff to open up. Goes with my screws. Okay, I'm just gonna set that aside. Pick up that screw before I forget where it went. Almost got away. And let's start with the floppy drive. So as I've said a few times, easiest way to get this floppy drive out, in my opinion, is to take the motherboard off and then take the screws out. You can take the whole chassis for the floppy drive off. Something I like to say when I get these open, because it's kind of like a PSA, is a little piece about the flyback. And we'll take a look in a second when I tip this over. Make sure I don't have anything in the way. Oh, it's stiff. Look how corroded that is. It's not only corroded there. It's pretty good. It looks like it's upgraded to maybe 4 megabytes. It can't be. It's got the resistor, if I'm not mistaken. Okay, let me say my piece about the flyback, and then we'll move on. No problem. Oh, look at this. This flyback is brown. Holy smokes, it's brown. It's also a perfect demo for 2 reasons. Interesting. Okay, I'll tell you the 2 reasons. Let me get my tweezers. First of all, super brown. This is the flyback, this cylinder. I can see it's chipping a little bit on the sides. It looks okay up here. This is like an epoxy glue. I'm not sure exactly what material it is, but it's a glue. And it's being used to seal the coil so that it doesn't oxidize through exposure, through just like regular atmospheric oxygen. But there's something specific about this revision, or this specific type of flyback, that's very noteworthy. You see this type where it doesn't have like a square beside it. It doesn't have a bleed resistor. And this is an earlier version of the analog board. And what it means is it won't naturally relieve any of the current inside of the flyback. It's important because this runs at 10 to 12,000 volts. And if you don't discharge this before working on it, you could find yourself the recipient, the unwilling recipient of 10 to 12,000 volts. And I don't want to find out, but I anticipate it's enough to put you into heart arrhythmia. So I'm going to show you right now what I do to discharge these. This doesn't need to be discharged. It's been sitting for a few weeks. Yeah, SADMAC 356. It definitely took me a little while to get comfortable with it. So I'm going to show you what I'm doing, and this is a standard procedure. The way that I'm doing it isn't the safest, and I'll show you the 2 reasons why it's not. First of all, this cord is very thin. The gauge of the wire is too high. It's worked just fine. I do this all the time. I don't think other people should. I do actually have a better one, which I made specifically for this purpose and subsequently buried under a bunch of stuff. Let's see. Oh my God. Yeah, here we go. So this is a better one for it. You can see it's got safer terminals on it, thicker gauge, higher quality. Anyway, this isn't actually going to discharge. So I have this connected to this ground cable, which grounds the CRT to the chassis. And I have this wire connected to the screwdriver, which is insulated. Absolutely do not want to be touching metal. And you lift this up. Oh, I've got my hand in the way. Lift this up and touch. And as you get close, you can actually tell how much voltage it is. As you approach it, it will spark. And the higher voltage it is, the more distance it will travel, which is why this cap has this big ring on it to protect the user. So you would touch it, and you might want to hold it for like 2 or 3 seconds, and that'll discharge the voltage. And that'll make this machine safe to work on. And if you've got, even if you don't have a bleed resistor, you want to do that. Or sorry, even if you do have a bleed resistor, you want to do that. But if you don't, you must do it. So I was pointing out earlier, this is very brown. That's noteworthy because it means there's a lot of wear on this flyback, a lot of hours, which is kind of interesting because if you look at the CRT itself, and if I had to guess, which I will, it looks like it must have been replaced at one time because this is very clear. Usually if they have a lot of hours on them, they would be pretty brown, and these back caps can get kind of yellowed as well. This one's very white. So I think at one point this might have got replaced. Yeah, it's safer. These caps can still have voltage in them, but with the shielding on them on the other side, it's much less likely you're going to get yourself shocked. Okay, and now I'm going to move on to taking that floppy out. But before I do that, I want to show you the screws I'm going to take out, and look at this mess. This was a $50 deal, so I can't complain about it. And I was able to get it booting, if I recall correctly. But screw, oh, you can't see that. Screw, 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 and screw. Those 4 hold this chassis in place, and that will allow the floppy drive to come right out. Now I'm going to do this laying down, but before I do it, I'm going to put on my handy dandy, oh wow, there's stuff falling out the back, CRT shield. Well, there's literally stuff falling out of this. What do I have? Oh, I know what that is. The thermosistor, which is a resistor designed to fail if it gets too hot, failed on this originally and blew up. And this is 1/2 of it. And then I have a tag, some kind of code, and then crap all over my workspace. Not that my workspace is the tidiest to begin with. Okay, let's put on the CRT shield. Because I'm going to be putting this face down, I put the CRT shield on it just to prevent any scratches or drama. The cardboard is flexible enough to take a lot of pressure. Okay, get my handy dandy automatic screwdriver. We'll take these 4 screws out. As I go through this process, there's going to be basically 4, I guess 5 pieces I'll go through. Why are you doing this? Listen to it. Go, 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 go. And then pause in between. It's weird. Anyway, my point being, you will take the top off the floppy drive, which is the eject mechanism. And we're also going to take the drive or motor drive for the eject off as well. Look at this thing. It looks worse in person than it does on camera. And I can just hear things falling out of it. It's so corroded and just landing on my desk. It's disgusting. Okay. So what I'll probably end up doing with a chassis that's that badly rusted or corroded is putting like a rust converter on it, which will prevent it from getting worse. Oh, wow, it's tight. Oh, I am suddenly thinking I might have already worked on this one. But I didn't take a note. Let me double check. I should have left a note for myself. No, if I worked on it, I didn't leave a note, so I don't think so. Part of the reason I thought I worked on it is because one of the screws was missing the washer. Wow, looks like someone's been in here. These look a bit worn. Okay. Let's find out what kind of surprises await us. Oh wow, I just saw something coming up there. Well, it looks generally okay considering how bad everything else is. Let's take a look. So the first thing I'm going to do is get what I call my baseline. I want to see how hard it is to put a disc in and eject. Oh, that went in super easy, but it was gummy. When it went down, it went like slowly down, whereas normally you'd expect it to just snap down. Coming up, a little gummy, definitely some resistance, but not bad. Watch when it goes down. This is kind of interesting. We should see a pretty stark difference. I think if you look at it from the side, you'll see that difference. So before I push it down, watch how this top piece goes down. You'll notice that it's kind of slow. See how it was like, meh. It was like, I'll get there. When this is all cleaned up, that's just going to snap right down. That's the way it would have done when it was factory new. Okay, so set this aside. We'll take this top gate off, or drive mechanism. First thing is going to be to push this little notch down so it goes flat. Second thing is going to be to change my tweezers because these are too flexible, low quality. Oh, those are too high quality. Where the heck did I put my tweezers? There. Okay. So these have springs on the side, and the warning I always give is when you're taking springs off electronics or really anything, they can go flying, including in your eye, but more commonly across the room. So you want to make sure to hold one end. In this case, these springs are clicked on one side. They're held in place by the design. You don't have to worry about it too much, but just a pro tip. Okay. The reason I'm taking this off first is it's going to allow me to manipulate the lower half a little more conveniently. Oops. So this is a design that I'm much more familiar with. And if you've watched my last two videos, you'll know that the eject mechanism was different. And instead of these retaining clips, it had screws. But this is handy because I can use this as a good example. I get to work on this. Okay, so now that I've got the mechanism out, I'm going to proceed to, well, I'll set this aside. We'll start with this. And this is a good demo. If you've never taken one of these apart, in my experience, this is the most common mechanism with these clips. And these clips are fragile. The plastic is brittle at best. And I think it was brittle when it was brand new. So rather than trying to push on this clip like this and pry it off, you can go into this slot here. Let's see if I can get this. Put your tweezers in and push back. And if you push back enough, gently, you'll be able to just lift this up with your fingernail. So I'll push, and there we go. Came right off, no drama. Okay, so the one that I cleaned last, or this morning actually, the gear was stuck inside, and as I started to try to take it off, it just fell to pieces. So let's see what happens today. Oh wow, it came off in one piece. One thing that's interesting to note about this is it's a pretty consistent color. Usually as these decay, they turn yellow and they get green spots where they touch the brass. Does this have a year on it? Usually the drive on the bottom has a year. It says 4092, which is interesting because it makes me wonder if it's really from 92. I don't know the production year when it ended for the Plus, but I've got a feeling it was before 92. Unless this is a replacement drive, I guess that's possible. Okay, getting back to the topic at hand, I'm just going to be cleaning this. So if you're doing a gear replacement, which is common, and I can explain why you might want to do a gear replacement, these will be steps that you'll need to follow, beginning with finding the things that you put away earlier. Where did I put them? Oh, they tipped. Okay. So these are going to be the main ingredients that I use here. I've got isopropyl. It says 99, it's actually 90. And then I have something called super lube. It's a synthetic grease, so it's a good replacement for the original grease. The other original grease I don't think is synthetic, or not completely synthetic, because it gets gummed up and congeals, kind of like animal grease. So let's take a look. One of the things I like to do when I'm taking these apart is remember the orientation of this. By default, it's typically in this orientation. And as I can see, that is the case with this one. It just makes it a little easier to put it back together. Okay. Just fill this up. I've got a clean Q-tip. And what I'm going to do is I'm going to clean out the old grease that's stuck in here. For some reason, I don't know if you can see this. Oh, you can. Yeah. See the shiny spot here and here? Inside I was cleaning, so it makes sense that it was shiny. But outside I was not. This is like some kind of oil that came from something. I've seen it on all of the drives. It doesn't need to be there, so I clean it off. You can see a little bit of green on the end of the Q-tip. That's from the old congealed grease. Okay, I'm reasonably content with that. If you're watching this, you'll pick up on a theme that I'm not going to go crazy with the cleaning. I'm not trying to get this perfect because the performance difference between perfect and reasonably clean is not noticeable. So it's not really worth my time or your time, in my opinion, to go and get these flawless. If you're into that kind of thing, you know, do you, but that's not going to be my video. Okay, this is grease. What I do is I get a little blob on the tip, and I take the profile of the blob. So like if the blob is sitting like this, turn sideways, and I get that profile and I touch it against the rail. And the reason is I just want to put a really fine amount on the rail. I'll touch the edge of the blob onto these gears so that as they spin, it distributes that grease around. And that, in my opinion, is good to go. So we put the yellow gear in first. And this would be the same procedure if you had a replacement. Let me describe that. What I have, just out of camera sight, is the remnants of 2, maybe 3 gears. This is what they normally look like. See what I mean when I say yellowed? See the color difference there. And then see this green spot? It's from contacting that brass drive gear. This is the one I think that just disintegrated when I was pulling it out. But nevertheless, this is what your replacement gear would look like. You'd pop it in with the small gear pointing up, and its mating gear has the small gear pointing down. Okay. So now what that means is this is ready to go back together. Well, almost actually, not entirely. Clean this up, getting the old crud off. What I'm going to do is I'm going to apply a little bit of grease to my, what is this called? A chem wipe. I like using these. I have a big pile of them I bought for soldering and cleaning flux. And I really like using them for cleanup. Okay. I'm just going to put a really fine layer of this on there, and it's just to prevent any further corrosion. This one was clean. It looks good. I want to keep it that way. So the first thing I'm doing is I'm putting these back two tongs or prods into their mating clips. See if I can get the lighting on that. It's probably a little too bright. Yeah. Anyway, two clips in the back, one in the front. And you might think, oh, just squeeze it shut. But you can actually break the edge of the clip off. It's very fragile. So what I do is I apply just a tiny amount of pressure, pull this pin back a little bit, like tip it back while it's inside, and it'll click into place. Okay, let's get this crap out of the way. Okay, so this is done. We can set that aside. Next is what we will call 1, 2, 3, 4 components. For these components, I'm going to first take off this piece. Oop, getting a little ahead of myself. I seem to do that every time. Take off this slide for the head first, just so it doesn't interfere as I'm taking this piece out. And slide this guy out. There we go. There's a bit of corrosion on there. If you look right there, a couple of small spots, and it might be dirt. That's corrosion. When I start going over this with my Q-tip, I'll be able to feel it'll get caught, kind of like a sandpaper feeling. That's how you can differentiate the corrosion. So just give this a general wipe. Just get like surface dust off and any grime that's accumulated. Gets hot in there. If there's any oil on it, the oil will congeal with any of the dust. Clean up these slides. This is where the floppy disk slides in. And this piece is clean as far as I'm concerned. Again, I'm not trying to get it perfect. Oh, wow. Interesting. Usually when I clean these, there's a lot of grease. That's just blood in there, all congealed and gross. Oh yeah, it says 91. This really might be a 92 shipped component, like a replacement maybe. And I was going to say, this is from factory with a lot of congealed grease. They must have stopped putting so much grease on there at a later point because it really isn't necessary and it just gums up. So what I'm doing is I'm cleaning 2 points or 3 that get really dirty, and you can actuate this and get the other side that's underneath this locking ring. That's pretty good. Now what I'm going to do is I'm going to take this, I'm going to apply a thicker coat. I'm not saying blobs, but a thicker coat. And I'll wipe off the excess because I just need a really thin coat on there. It'll last a long time. It's synthetic, so it's not any major concerns about that. Oh, I put too much down. I'll have to wipe it off. Okay. And what I do is when I put on a thicker coat, I'm going to wipe it, but I'm not trying to wipe it off. I just want to like distribute it a bit. So it doesn't have these big gobs. The reason for that is the big pieces will just accumulate dust and will kind of inhibit the flow if they start to get gummy from dust. I'm taking this, some of that grease that I cleaned up, and I'm wiping it on the corroded spots to seal them. So they, ideally, optimistically, don't get more corroded. I'm just going to wipe the bottom where I cleaned with isopropyl to kind of put a thin layer of grease down. Okay, I'm happy with that. That's done. Okay. I'll give the same warning I give every time I do this. This tray, in order to clean it, you have to take these 4 discs off. I don't think there's replacements for them. So if you choose to do this, be very careful. The steps I use to take them off is I take the tip of the tweezers, put it as far back under it as I can, and I pull it up towards my finger. And the goal is to lift it without flexing it as much as possible. One of these, last time I did this, tried to escape from me, so I'm going to try to take better care. Ooh, sometimes you might poke yourself in the finger, like I just did. Felt great. But I guess the plus side is that didn't bend the ring. Again, if you lose these or damage them, you might be very disappointed to find there is no replacement. It's not that I know of. Okay, this comes off and we can see what kind of, oh, I was going to say what kind of mess is underneath it, but it's generally pretty good. By this point, I've usually used like 2 or 3 Q-tips, and I'm still on my first one. So this is a generally clean drive. Oh, this is interesting. Another piece of corrosion right here. Otherwise, it looks good. So there's 4 little dots here, 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 and here. And you might be able to see the top of them is a little bit shiny. This plate, among other locations, will glide on those 4 dots. So I'm cleaning them because they have grease on them. And I'm going to clean this. This is where they slide because it has grease on it as well. And I will clean this all up. Now, this isn't necessary to clean this, but I just like to clean it because it looks pretty gross and you can generally kind of see it from the outside. Okay. Another tip I'll give is if you're cleaning, you're using isopropyl alcohol or any kind of solvent, and you start cleaning these marks, see this numbering? You will take off that numbering, and I'll demonstrate that right now. See it's coming off? So if you care about this stuff, don't clean it. Just clean around it or leave it be. Okay. Because I've seen corrosion on this, yeah, totally try not to break or lose them. The reason I was putting my finger over the top of them when I'm lifting them off isn't because I love poking myself in the finger. You can kind of see the mark where I did that. It's because I don't want it to go flying in the same vein as a spring. So we're ready to go. So I've got a blob. Again, my goal isn't to put blobs down. Never is my goal to put blobs down. Just want to put a little layer down where this is going to slide. And I'm going to come back later and kind of spread that around with my cloth, my chem wipe. So even if I put a blob down accidentally, which I don't want to do, it will get wiped later. I'm putting them down here. Remember those feet I described? I can see where they glide here. I'll put some back here as well. This one is a blob. I don't want that. Spread it around. Okay, I'm generally satisfied with the distribution here. Now I wiped this all with rubbing alcohol, which means if it did have a layer of grease on it protecting it, it's gone now. So I'm going to actually go over this whole thing with the grease that I'm moving around that I just applied, and it should apply or provide just a little bit of protection. Clean this here, this here. Now, before I close this up, I have the option of doing something that I prefer to do, which is putting deoxit on these switches. This is the read-only switches, I think. And deoxit is a genius. They made it so when you spray your bottle and you get a drop onto the tip, about 10 drops come out of there. So you're paying for a full bottle, but getting about 1/10 of it. So what I do is I put this little cap underneath. And the reason I spray it at this specific orientation is there's a hole in the the switch right here. I'm trying to spray it into the switch. Okay, let me set that aside. Now I'll take this and actuate my switch. These switches were working to the best of my knowledge, but this could extend their lifetime pretty significantly. So why not? It's cheap and easy. Okay. In my opinion, that's part done. This also needs a little bit of grease. Yeah, it's kind of dirty. I'm going to give this a clean. Actually, I'll just wipe it with the grease cloth. I've noticed that when I wipe with the grease cloth, it picks up a lot of the old dirt, and it is kind of mixing old and new grease, but this doesn't have very much on it to begin with, so I don't feel bad about that. I'm also going to apply a small amount of grease around these feet that I described earlier, because I know that it slides there. And on the opposite side, I'm going to flip it over and apply a small amount of grease at the top. This is where those discs are situated. And I'll come back and wipe that over as well. Okay. Oh, wow. Don't need that much. Definitely do not need that much. Cool. Happy with that. Let's go ahead and give this just a wipe around a little bit. Cover this over with some grease. Okay, I'm happy with that. So this was actually sliding pretty freely before. I've had these before. They're gummy. You can tell the difference. Oh, this one feels a little rough. Let me just double check. Well, there is some corrosion here. Yeah, and dirt. It's corrosion. It's not going to fix. So it feels a little, not like sandpapery, but you know, just got a texture to it as it slides. If I like to poke myself, I might take up sewing. Fortunately, I've never sewed my finger, although I think I've seen it once. Yeah, I've seen it once. Not a good time. All right, let's put our discs back on. Putting the disc back on is pretty straightforward. Line it up over the hole. Take the tweezers, and I'll describe this, the way this works. This post, these 4 posts that the disc slide over, it's like a cylinder with, imagine the cylinder with a cutout around the inside, like a band. And the disc slides over the top of the cylinder and hooks into the band. So it basically expands, goes down, and goes back in. So what I'm going to do is I'm going to get one side started, hold it with my finger, and I really only have to move like 2 millimeters, and it should pop right back in. And it just did. It's that simple. So we'll do that a couple more times. We get one side started, move over a few millimeters, and oh, I dented it. It's okay though. I got away with it. You might be able to see it. Can you see it? There's like a little dent right here. You can't see it. It's pretty minor. It's because I was poking down a bit. One side started, move over. Come on, bud. One side started, move over, and there we go. Looks good. And same here. The first time you put these on, after taking them off, you might be like, I can't tell if it's on. All I have to do is give it a little wiggle. And watch, like, I'm flicking the edge of it. Flick, 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 not going anywhere. So it's on. Interesting. I can feel it sliding over something dirty, but definitely not ideal. Definitely not how I prefer to do this, but it is what it is. Okay. We've got the top piece, the last piece. We're going to take the head out, the reed head. We're going to clean the reed head. We're going to clean the worm gear, which I can see is filthy already. It's easily the filthiest thing on this entire thing every time. And just give it a quick inspection. So it starts with these 2 ribbon cables that are stiff. And then there's 2 screws. The screws are holding a rail in place that the reed head slides across. I'll show you what that looks like in a second. Okay, screws. Now this is going to come forward, fold up towards the screen, and come right out. And this is a good example of a filthy reed head. I'll show you what that means. There's a piece here, which is hard to show on camera. This is a little metal tong that sticks out. Let's see if I can show you. And it catches on top of this worm gear. And as it spins, it moves the head forward and backward. The grease just builds up inside of here, and it always has a filthy blob of grease inside. So what I usually do is take one of my Q-tips that have already been sullied and clean that blob out because it's pretty nasty. Okay, I am reasonably content with that. It's not perfect, but it's so much better than it was before. Okay, that's good. This is the part where it is downright filthy. You can see that. This yellow thing is not a component. It is a blob of grease. So first, because I'm going to be touching this in a moment, I'm going to clean the screw. And after I clean the screw, we'll come back and we'll clean that blob. This was already a kind of a dirty Q-tip. I should have started with a clean one so you could see how dirty it gets here. This is where you want to pay a little extra attention getting it cleaned up, because it really does get exceptionally filthy here. Okay, so you can see that's a black Q-tip. Disgusting. Start with a clean one, and even having rubbed it with the cleaner Q-tip, which is now black, this should probably still get pretty dirty as I go. Yeah, I can see it's getting dirty. And we still have that big blob at the back. Okay, let's get the glob. Tasty. It's like cleaning your ears after like a month, maybe. Sorry, it's disgusting. Okay, that's clean enough. I'm good with that. So now that we have it in a reasonably clean state, we can clean out our Q-tip. Get some new grease. I'm going to use the same profile trick, except this time, rather than put a blob down, I'm going to put the profile of the grease along the edge of these. And I want to just distribute a little piece of it in each of these threads from the worm gear. I don't want to put a lot down. Again, if I put a lot down, it just means in 10 years, 15 years, it'll accumulate dust and get gummy. The exact same way it was when I took it off. So put down a little bit, and when it moves the next time, it will do the work of spreading it around for me. I know I said this was clean and I was happy with it, but I lied. It's gross, and I'm not happy with it. Okay. Oh, I almost forgot. I'm going to clean the heads. Another tip I want to give is these heads. It's two separate heads. So as I flex this, boing, 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 they open up. There's a thin piece of metal right here. Can you see it? Right there. That is holding the two of them together. If you bend it by forcing it open too wide, it will permanently stay open. The only way to bend it back is to bend it the other way, but the heads touch. You have to take the whole thing apart to do that. And or at least from what I've seen, the success rate is not high. So just be very conscious when you're manipulating these heads, not to bend that metal. And of course, it's very delicate. So what I'm doing is I'm holding this open with my thumb so that when the Q-tip is inside, it's just barely touching the sides. Realistically, this is probably clean enough that I may not have needed to do that, but I have it open, so why not? Okay, there's my clean Q-tip, and we're ready to go back together. So we can squeeze this back into place like so. Get this rail so it's aligned with the back correctly. So the rail ends here and the rail guide ends there. And put those two screws back in place. These lock the rail in place. Oh, it moved when I put the screw in, so I'm going to have to revisit it before I tighten it down. So I slide it forward. I'm holding it in place. There we go. Now I don't have to worry about that with the second screw. It just goes in. Like so. And you might notice that I turn the other way, like I'm taking it out. It's intentional so that I find the thread that it was originally placed in. It clicks into place, falls into that thread, and I can just tighten it up. I don't have to worry about cross-threading anything. Okay, now making sure that I didn't skip anything here. We're ready to put this back in. So this goes into this cutout. This goes into this cutout. Hello, friend. Please go in. I only have so much patience. And so what I did was I got these back 2 clips in, and now I can kind of shimmy this around. I kind of shimmy this around so that all the pieces go where I need them to. I'm having some trouble here, and I think the problem is I had this too far back. So I can just slide it a smidge, and then this is like 95% in place. And the reason I'm having trouble right now is this clip right here is in the way. So what I need to do is put this side in first, like so. And that was it. I just needed to tip it underneath this clip. So this is almost done. Almost. I just need to take these springs. I can take one of the prongs on my tweezers and guide that over the clip. There's one. And there's 2. This is almost ready. I also like to put a little bit of grease on this. It's absolutely not necessary, but knowing that it does have some wear across it, I like to put grease down and leave a very thin layer because this is plastic on plastic. It doesn't really need grease to begin with. Oh, I forgot a step. I didn't put my cables back in. Thankfully, I should be able to push this out of the way and get at least one of them in. It's going to be pretty challenging to get this second one in. Let's see if I can get it started with my tweezers. And I can use my finger to push it in the remainder. Yeah, that's challenging. It doesn't really want to go. Well, note to anyone watching, that is so much easier to do without this top on. Okay, now we're ready to put this on and do a test. One of 2 tests. The first test. Oh, wow, that's so much better. So you might remember at the very beginning, if you were watching, when you put the disc in, it was kind of like, you know, I'll go down, but I'm taking my time. Now it just snaps right down. It's much better. It feels good. This is an example of a floppy drive that did need a little bit of maintenance. Generally, this was pretty good though. So let's eject. Put our eject drive back in. Nice thing about this eject drive is I can test it tonight. The last few that I've been doing, the gears, as I noted, had disintegrated, which means I can't test them until I get my replacements. And my replacements were designed by me, open sourced, and made available to the public. Because if you want to buy replacements, you're going to find people selling them for like $15 and $20 on eBay. And they're high quality replacements. So I'm not disparaging what they've produced. I just don't like the price. Mine are $8 for a set of like, I think 4. I honestly don't know, but you can get 4 for $8 or something like 10 for $8 because of the way Shapeways pricing works. So you can give them to your friends if you need to. All right, let's put this back. The way that I know which way to point the floppy drive, well, you could use this as a clue, but there's an easier one in my opinion. This tab is the back. And the front, when I say front, means the direction that goes towards where you insert the floppy disk. Okay. I made a note for myself on this Mac because I worked on it a few weeks ago that I wanted to check the power pot. It's like pot resistor 56, I think, on the analog board. I don't know what it's on right now, but apparently I made a note 2 weeks ago that it's noteworthy. It might be on a high setting. So I'm going to test that first. Oh, you're being a jerk. This is in there a little bit crooked, maybe. Ow. Doesn't want to line up very well. Yeah, it's not on center. Try putting this one in first, and maybe I can lock it into place that the other one is a little easier. Yeah, I think that'll help. Yep, got it. So now I can lock up these two. These are worn. Someone has been in here before. And I kind of suspect this could be a replacement floppy drive as well. The reason I think it's replacements is because when I look at the analog board, the flyback is very worn. It has a lot of hours on it. It's very brown. It's crispy, speaking frankly. And it's a good indicator that it has a lot of hours on it. So I'm putting this back in. It has a memory from sitting for so many years. So I want to put it back the way that it was originally. Okay, we can see it was like that. So let's put the floppy drive back. We're not going to focus on testing the floppy drive just yet because I want to test that pot. But to test the pot, I'm actually going to take the analog board out. I don't like working on it inside the computer. So let me put away some of these things so I don't spill anything on my analog board while it has 120 volts going to it. Before I do that, look, label floating around. What is this? Looks like it might have come off the CRT. Usually a label down the bottom. Okay. I'm just going to put this in to get it out of the way. Now those 4 screws that I took off originally are now going to go back in. The way that I have this oriented, the screws will be, in my experience, pretty much perfectly aligned, and it'll just be a matter of putting them in. And this screwdriver will save your wrist big time. I'm not a spring chicken anymore. I'm not old by any means, but I've noticed, after 10 years of sitting at a desk full time, more really, my wrists start to get achy breaky pretty quickly. Hello, friend. Please go. There we go. Okay. That is that. So let's take out the analog board. And I have a CRT I use for testing, so that won't be a problem. If you haven't taken an analog board out of a Mac before, there's 3 screws you have to take out. Well, 4. There's 2 here, or there should be 2 here, depending on who's worked on it before you. Oh man, these are so corroded. This corrosion, the battery fails. And like all good designs, distributes acids and corrosive vapors through your vintage electronics. Oh, come on. I have to take this one out manually. It's too stiff. It's rusted. So I'm just putting these to the side. That was 3 screws. The 4th is this grounding screw here. Oh man, it's super rusty. Okay. It's funny. You can probably see it. Your eyes are not deceiving you. Those are green. Okay. So the first thing I like to do is get it loose and take off this clip in the back. And I can take off the flyback cathode. And that's called the cathode cap. And what you want to do is you want to be really careful when you pull this one off, because if you bump this part of the tube with your hand as it comes off suddenly, you can crack this and that will destroy the tube. It won't work after that. So what I do is I rest my hand against the battery tray and I apply pressure against the battery tray. Okay. So we're going to take this chassis and CRT and put it to the side. And we're going to get my test setup going here. This is not perfect and it's not safe, but it lets me test these comfortably, reliably. Okay. So the pot that I'm talking about is right here. It's R56. Put this in. This one here. This kind of simulates what the board might look like inside of the case when it's there. And this has two clips on it. Peel this back. If you can see, one clip there, one clip there. There's a small hole. Best way to do it that I've found is get one side in, push down, and now I have both sides and it's secure. If you can kind of wiggle it like this without it popping out, then you know that it's okay. Now this is where my beefier grounding strap comes into play. This will hold the ground to the CRT and serve as a makeshift chassis ground. Okay, let's just see. I need my floppy drive. So I can plug in my floppy drive. I'm just going to bring this, it might go in a view a little bit for you. I need to bring this a little closer to the edge of my desk, because this is going to end up hanging over the edge of the desk. Okay, that's good. So now what I'm going to do is I'm taking the grounding clip and the grounding strap from the analog board, connecting it to the logic board with that same ground. So I now have like a grounding system across the whole configuration. Another thing that I have that you might not have is a ground isolated transformer, which means that this system is running on its own isolated ground. So if I touch something that's electrified, I'm less likely of getting a shock, significantly less likely. And then also I have a variac, so I can control the voltage if I need to. I have a current limiter. It's called a dim bulb tester. I use it to restrict the current that goes into the machine so that if some of these components want to terminate their life, it'll be a little harder for them to get the current for them to do that. And then I also have a monitor that I built, which I cannot bring into frame. Let me see. I'll just unplug it, which shows me some information about this setup as it's running. So I'll see if I can leave that in frame. Is this too far away? There we go. And see if we can get some test data that you can see and I can see. Okay. We are almost ready. There's one vital component missing from this, a power cable. Okay, power cable, voila. And this is a OG Apple cable too, which is kind of cool. Not necessary, but cool. What I'm doing when I'm putting this in, and I'm checking and I'm double checking for my own safety and for the safety of this equipment so it doesn't get burned out. I am checking the position of this switch. Just from familiarity, I know that if this top is down, it's in an on position. You want to make sure that the bottom is down. And I'm double and triple checking. I don't think that I would get a shock, but I simultaneously really don't want to find out, and neither should you. Okay. So this has a number of safety switches set up before I get to this point. So I turn on my ground isolation. turn on my Variac, turn on my dim bulb tester. This is the order that they're plugged in as well. And then finally turn on my monitor. All right, let's see what we've got. So we're getting 130 volts in. So I know my Variac needs to come down. And 116, 119. Oh, I'm looking at it upside down. Okay, 120, here we come. There we go. 60 hertz. This will show me my energy consumption and power factor. What I want to see from this, if everything's working right, is between, let's say 24 and 30 volts. Before I turn this on and test any further, I'm going to check what this pot R56, what resistance it's set to. And my guess, just looking at it, is it's around 180, maybe 190, and that's ohms. So let's set this up, make sure that y'all can see it. And let's find out if I'm wrong. There's 1, 2, and it is reading nothing. Oh, because I have it on volts. I'm dumb. Wrong 200. I need to get a better multimeter. 1. Dubious. I don't believe you. What is going on here? How could this be failing? 1? So it's over 1,000? Or, well, in this case, over 200. I'd guessed 190. Let's see what it says. Holy smokes. So it is high. 234 is high. This maxes out at 400. For most of mine, I only need to go around 150, 180 ohms. And in my opinion, 180 ohms is high. So what I'm going to do is I'm going to set this up. You won't be able to see where I'm grounding, but just trust that I'm grounding. And I'm going to read the voltage off the 12-volt rail and boot this up. Okay, now I'm steering clear of this because this is 120 volts at the end of the day and 15 amps. I have a current limiter on it. It's limited to about 1 amp. 1 amp will still do the trick if you're looking to get the early ticket off the solar system, but much less likely to do the trick. So here we go. That's a good sound. My probe is stuck. I forget which one is the 12 rail. 4.78, that's good. I mean, it is a little high. Let's check these. 12, oh yeah, look at that, 12.6. That's high, high, high. 12.24, this is too high. Let me just grab an insulated screwdriver. Bear with me for a moment. You know what, I'm lazy. My insulated screwdriver is behind a whole bunch of stuff right now, so I'm gonna do something we'll describe as entertaining. I don't like doing this. I don't like doing this at all. All right, I'm gonna get the insulated screwdriver, which kind of sucks. I had a tool made out of wood for this that I had to recently sacrifice to fix a broom of all things. So I'm back to using my insulated screwdrivers, which is probably better for my own safety. I think it's only 12, no, maybe 30 or 60 volts going across that, but I don't want to damage the analog board. Where I put my screwdriver. Voila. Okay. If you've never seen an insulated screwdriver, this is what it looks like. The tip of it has the metal screwdriver bit, and it has a long insulation shaft. So I'm going to line this up with that pot. I'm going to line this up with the pot. I'm going to take my doodad. I want you to be able to see it too. And I'm going to put it on my 12 volt, which I think was this one. I'm going to bring that back down to 12. I am going to bring that back down to 12. Okay. Perfect, on the money. Let's check our 5 volt now. Should be closer to like 6.86. I'm saying 4.6. Yeah, 4.68, right on the money. Okay, I'm happy with that. So we checked the pot. It's in a better place. You can't see it, but this monitor is on and it's flashing a floppy drive. You should take note of this. 29.6 watts. Is that 29? Yeah, it's 29. It's a little high. It's kind of unusual. It indicates to me that maybe something on this is being strained. So I'm going to take a little picture with my thermal camera, and we will, come on, buddy, boot up. We'll get a sense of what this looks like. You won't be able to see it initially. The reason I'm taking this, though, is I want to start cataloging these so I can come up with what is a normal expectation. Oh, I pressed the wrong button. Hello, wake up. Thank you. This looks good. Cool. So I just took a picture of it. You can't see it, it's gone. But it's going to allow me to create an archive or reference of what normal is supposed to look like for these machines. And it should help me create a scenario where I can look up what's normal versus a picture I take of a faulty board, and maybe, if I'm lucky, easily identify faulty parts. Okay, we're done. We're done with the test. I'm going to show you the discharge. So I turn this off. I'm going to get my yellow alligator clip. And if you've never seen this at home before, you're about to be amazed. Screwdriver. And we're going to put this under the cathode clip. Watch and listen. 2 clicks. One was, in the neighborhood of 7 to 10,000 volts. Probably not the full voltage you would expect, which is about 12. And the second one was much smaller. That is what you'd expect to see on an old style flyback, which doesn't have a bleed resistor. Whereas if it does have a bleed resistor, you probably won't get any visible spark or pop at all. And that makes this safe to touch. I don't plan to touch it, but if I accidentally brush against it, it's safe. I'm going to turn this off, and this acts as an additional safety for me, so that if I brush up against, because this area is live, all of this is live, even when the power switch is off. Yuki, I'm ready to put away my test monitor and put this back in the body and see how badly I messed up the floppy. I mean, see how much I fixed the floppy. Okay, come on, bud. These diodes back here can get pretty hot, like maybe 60 degrees, maybe hotter, I don't know. But something to be mindful of, you don't burn yourself on them. I haven't done it, but just touching it is pretty warm. Which unsurprisingly is why they have the heat sinks. Okay, put away my test monitor, tube, and it's safe at home. And we can take this apart and put it back in the machine. Come on, buddy. Come on. There we go. Okay. I'm gonna just, I'll leave this here for now. I can get rid of this though. Don't need this. Where'd my cup go? Oh yes, it's collecting all my drops of deoxit because it's a crappy bottle. Okay. Oh, I wanted to check the resistor on the motherboard. So I actually do need this. Let's check that really quick. So it was 239 before we started this wonderful adventure, and I turned it down a tweak. I'm going to guess it's closer to 190. Oh, almost hit the wrong one. 180, and we'll go with 190. It's going to keep rising until it settles, which can take a minute. 190, close enough. I'm good with it. I called it. Okay. I'm happy with that. Put the screwdrivers away for another day. I'll leave this insulated one out. And we are ready to put this back in the motherboard, or in the case. Okay. When I pick up these chassis, I like to hook my fingers under this front edge and hold the rest of the weight on these back. Okay. So putting the analog back in, a couple of simple considerations to take into mind. There's two clips, one here and one here, that the analog board will rest into. And then there's this brightness knob, which has a cutout in the front here. I typically put the cutout knob in first, line up the cutout or the clip, and try to seat it, which I did successfully on the first try. And I can get this top clip. Once the top clip is in, there's a little alignment notch up here. I'm pretty much good to go at that point. Oh man, this is tough. I don't know that. Yeah, I got it. Okay. Okay, and again, we can push in one side. And the test is if I can wobble it. I can. Okay, this is ready for the motherboard. Actually, no, it's not. It's ready for its screws. These screws are in horrible condition. Like, they're very corroded. Okay, here's one. Should be three, and then this little grounding pad. Okay. This can get a little annoying because these two screws at the back have to line up with the chassis. And the only way to really confirm is to peek through them. You have to like scoot over and try to look around in here. Oh, I got them. They're good. It's usually a little more tricky. I think because it's so corroded, it kind of holds itself in place like a pressure fit. Whereas normally it isn't quite so cooperative. It's crispy. I'm at a point with this, I'm happy closing it back up, so I'm going to put these screws in and close it up and test the floppy drive directly. I have a very high level of confidence that this floppy drive is in good working order after that inspection. And this is the last of the three screws that go into the analog board. Put this back down. I've got my CRT shield on. Put something interesting to note. I guess another confirmation that I'm not the first person to get in here. This doesn't have a paper shield on it. Normally they have like a paper plastic metal combination. Oh, that's so stiff and rusted. It's gross. Oh, come on. But it's missing from this one, so roll with the punches. A lot of that is like EMF shielding. I guess there was a lot more noise created by electronics back in the day, 35 years ago. And that shielding was more necessary than it is today. Okay, let's put the top on. This is very yellowed. Also, I because this is already so yellowed, I volunteered it as a test subject for something, and I'll show you when I flip this around and get it closed up. This is my test subject for the deletion of the Mac Plus silk screening on the front face. If that doesn't make any sense to you right now, it will momentarily. Oh boy, I did something funny with my screws. I put them in a place I don't normally put them. Okay. This doesn't really look like it's on completely straight. So let me just take a quick peek. It's okay. So I start the screws by hand. If you misthread these, they will cut new threads and damage the screw slot, even the screw sometimes, especially in metal. I don't want to do that. I want this to stay as much as possible in good shape. So before I use a drill to put them in, I always put them in by hand just to get them started. That click you hear is the clutch. I have this set to a lower clutch so that it doesn't damage the plastic when I put these screws in. It's just an easy way to make sure that I'm playing it safe. Some screwdrivers don't have a clutch, so it's good to get one that does. The reason I'm spinning it by hand is I'm trying to find the beginning of the thread. These ones I always have a hard time feeling it. It might just because of the extension. Oh, I felt it that time. Okay, we're good. We're ready to test. Okay, so I'm going to take my CRT shield off because we're done putting that face down. Put my thingamajigger back on. Come on, buddy. Go back on. How come you don't? Oh, I didn't put that screw in because I'm derpy. There we go. Now I'll show you what I'm talking about when I say Macintosh delete. This at one point said Macintosh Plus. However, it no longer says that. I don't like it. I think it looks bad. The 512 and 128 doesn't include that. However, what I did was I took something very powerful, a carb throttle body cleaner. This is like a super strong solvent. And I went over the silk screening and it softened and removed the silk screening. In the process though, if you ever look closely at your Mac, you probably feel it with your fingers. It has a very fine texture. Listen to, you might not be able to hear this, but if you can, this is smoother. It's lost probably like 50% of its texture because of the carb cleaner. And you can see it's discolored, but this hasn't been retro brighted or cleaned up yet. Okay. Let's plug this in and we will test the floppy drive. So I'm expecting probably by the end of the week to have replacement gears in stock. This will be those 3D printed gears that I mentioned. And I'm going to do some more videos of the gears being installed. It'll be very similar to the maintenance that you just saw, but it will give you a chance to hear the new gears. I haven't had the opportunity to use the gears I designed that have become somewhat successful personally, but I've heard feedback that they whine a little bit. Okay, where's my test floppy? Right here. Floppy. Now we're going to see if it all worked. Let me see if I can show you the amazement. Okay. Of course, that's a good sign to start. Just going to play with the brightness adjustment. Oh, look at that. Wowie. So that's what the note was for. The note is for this pot, not the voltage pot. The brightness pot is worn and has spots in it. It does nothing until you get to about 90%. Oh, there you go. There's your answer. The answer is it works just fine. So I have to take this apart anyway later and repair that pot. I might have to replace it. But that's a good case for the deoxit. You can spray that on there and move it around, and it'll free up any oxidization or any other crud that's in there. All right, that's it. That's the end of the show. I'll be doing more of these again, like I mentioned, to install the replacement floppy drive gears. I'm also going to do some investigation on analog boards. I have an analog board that I just cannot get to work. It's been recapped. I double checked that I didn't mess anything up, but it just clicks. It crossbars. Click, 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 click. So until then, ta-ta for now. And I hope you have a good evening.